Good morning, good afternoon, good evening. I would like to welcome you to webinar 24 in the Eijkelkamp North America CPT webinar series dealing with CPT'22. At least that's the topic for this webinar. CPT'22. I just returned from that conference in Italy. And you may wonder, why do I make that the topic of a webinar, especially when I announced it well before CPT'22 was held? Well, CPT'22 is kind of a different conference, and it's not necessarily the first one. Back in the 1990s, it was felt that it was necessary to have a dedicated conference dedicated to CPT. And that was held, but unfortunately after that the series basically fell flat and nothing happened until Peter Robertson with Greg Drilling decided in 2008 or so to reinvigorate this series. And so the next one, officially the second one, as you see on your screen on the left, the second International Symposium on Comp Penetration Testing was held in 2010 in Huntington Beach, California. And it was agreed there that we really were going to try to make this an event that would occur every 4 years. And so in 2014, we were in Las Vegas, again organized by Peter. And then it was felt that, hey, this is now something that is continuing. So in 2018, the conference was held in Delft in the Netherlands at the Technical University there. And then very recently in Bologna. The beauty of this conference is really that we are trying to spread the news, spread the gospel, if you want, the good news about CPT. And therefore, all the conference proceedings are open source. And I really would encourage you, if you're interested in CPT, to find these proceedings online. If you have a hard time with it, let me know. More than happy to share with you. And even though you may wonder, well, why would I go back to proceedings, say, from 2010? Well, they're very informative presentations made and papers written at the time, one of which was that people from around the world were asked to tell how CPT is being utilized in different countries in their region. But all in all, yeah, very interesting information in those proceedings. And then, as I mentioned, last week, we were in Bologna, Italy. Here you see the historic medieval downtown area with the Piazza Maggiore, the center of this picture for CPT'22. For those of you that are not familiar with Bologna, it's right smack in between Florence and Venice in northern Italy. And there we had an event from Wednesday through Friday. And there you see the proceedings that were being produced as part of that conference. And before I go to some of the specific details there, I want to give you a flavor, a couple things, a couple highlights to really set the scene, not only for this conference, but really what CPT is all about. And one of the things that was done, it's just like with every conference, there were keynote addresses, and one of which was by Barry Lehan from the University of Western Australia on new CPT methods for the evaluation of the actual capacity of driven piles. In other words, how do you use CPT data to really calculate the capacity of a driven pile? And right now, the ISO organization is working on a better correlation for that. And Barry gave a very interesting presentation to summarize the findings. And you may want to look at that paper if you're interested in actual capacity of driven piles. Topic that we've covered before in this webinar as well. But there you see the latest thinking on that. Then there were invited papers. And I want to highlight just two of them. One was by Roy Santos from Orsted, where he talked about the uncertainties associated with CPT data acquisition. And that, to me, without going into the details of his paper, that to me is a very important thing to realize. Yes, I am a conehead. Yes, I strongly believe that CPT is a very useful and probably the most efficient soil investigation technique. But we should always remember that no technique, no testing method, no investigation method is perfect. And there are uncertainties associated with CPT data acquisition. We don't necessarily get the correct data all the time. And therefore, we need to be aware that when you do your CPT, when you acquire your data, what the limitations are, what the uncertainties are when it comes to your equipment that you're using, so that you can interpret the data properly. The other presentation was by David White, CPT equipment, recent advances, and future perspectives. And again, an interesting paper, and I'll come to some of the details in a few minutes, because CPT, as you may not know, is basically celebrating this year its 90th birthday. Back in the early 1930s, CPT, although at that time mechanical CPT, was first developed. And by now we have a technique that has been around for about 90 years. I may argue that was mechanical CPT. Well, if we go to electrical CPT, that came out in the early 1970s, so it's about 50th birthday. Even though these techniques are well established, there are still advances. There are still future developments. And that is something that was made very clear in this presentation. And then finally, apart from these keynote addresses and invited papers, there were a whole bunch of technical papers, I think close to 150 of them, dealing with equipment and procedures, dealing with interpretation, and dealing with the applications. And what I want to do is highlight one of those papers from the first section, in a way, because I'm biased. That was a presentation that I gave. And again, it ties in with the uncertainties associated with CPT data acquisition, deals with advances, potential advances in future developments in there as well. So that's why I picked that paper to give you a flavor again of what was presented at that conference. But before I do that, let's go back to what was put together in White's paper. What you see here, the screen at the top left-hand corner, is something that I've talked about it before as well. When I talk about CPT, I talk about the carrier, I talk about the pusher, I talk about the electrical CPT system, and then I talk about the modules. Well, White put in his presentation a slightly different split. He talked about delivery. How does the CPT equipment reaches the site? In other words, the carrier. How does the CPT advances into the subsoil? Basically the pusher. And then he talks about some other things about what kind of measurement do you use, what kind of cone do you use. And there you see a picture that he is using quite a bit, using the traditional way. Now we have a truck, or if you do it offshore, a seabed frame, where we push the cone into the ground at 2 centimeters per second, at 0.8 inches per second. And we do that using a reaction force at the surface, and we measure the tip, the pore, and the sleeve, and we do that with a cone. And he has given here a standard cone of 10 centimeters square, which has a diameter of about 36 millimeters. Standard approach. Of course, now we can keep on doing this, and of course we can say, well, this works fine. But what he challenges us to do is to start looking at different approaches. And what he put together was really a very interesting little graph, where you still see the standard delivery with a truck, but maybe the truck is no longer a diesel engine truck, but an electric vehicle or hybrid vehicle. But we can also start thinking about dropping the cone from a drone, or use some kind of unmanned vehicles that drive around and somehow put the cone in the ground. Yeah, remote operated vehicles offshore. all kinds of different options that you have there that may be doing something in the future. And then when it comes to the sensing, we may start sensing actually the flow or the lateral stress or the temperature, not just the tip, the sleeve, and the pore pressure, but all kinds of other things in there. And when it comes to the movement of the cone, you start seeing instead of just a static movement 2 centimeters per second down, maybe we can do it at variable speeds. Or maybe we can combine vibration and the static movement, the sonic testing, the sonic CPT that I've talked about in the past. All kinds of different ways that he highlighted in there. And the reason why I show this is to really help you understand that CPT as we know it today may not be CPT as we will know it 50 years from now. And that was one of the things that Peter Robertson in his opening address mentioned as well, that where we are now is not where we got started when CPT was first developed, but that the developments definitely haven't ended, and we will still have something to go in the future. So that gives you an indication of some of the topics that what was talked about at the conference. I then want to go and give you a summary of what of a paper that Eric Basiv and myself presented at this conference, methodologies for obtaining true cone tip resistance values or cone bearing estimates, but it's basically your tip resistance from blurred and noisy measurements. A very long title, and you may wonder, what is it all about? Well, let me explain to you what the story is. You've seen, if you've come to these webinars before, you've seen this graph time and time again, and it kind of represents what David White also put in his standard approach. We're pushing a cone into the ground 2 centimeters per second, and we just take all these measurements, and there we go. And what we measure is, among others, the tip resistance. And the tip resistance is, as you see here by the red arrow, supposedly what the cone or the soil pushes against the cone tip. But in reality, that is not really what we measure. If you get these squiggly lines, as Paul Main refers to, and we put in there, you see that we use their QT. And QT is the value that we report, but that is not necessarily what we actually measure. We measure QC. And the reason that we do that is very simple. Here you see a cone, and that cone, as we push it into the ground, sees resistance illustrated by this orange arrow, which is the soil resistance. But at the same time, on the back of the cone tip, the pore pressure, the hydrostatic or the dynamic pore pressure that we have, is pushing in the opposite direction. And that means that the value that we measure, which is QC, because that's really the sum of that resistance from the soil and then partially compensated by the pore pressure acting on the back of the cone. So the QC, we need to correct that, and we need to do that as a factor of the pore pressure. And that gets us the QT. That gets us supposedly the true pressure that the soil is pushing against the cone tip. And as I mentioned before, in granular soils, that correction is not that essential, simply because the pore pressure is not that high. But in cohesive soils, it must be applied. And as a result of that, the industry has gone that we no longer, virtually any time, look at the QC. We always report the QT. And with that QT, we then started getting these familiar figures, where you see the soil behavior classification. And on the vertical axis, you see that we're using the QT. And we use it either with the friction ratio or with the pore pressure, and we figure out what kind of area we are in, and therefore what the soil behavior is. And we did this for a long time. But then we started to realize that it is really not the right thing to do. So we need only need to go from QC to QT. We needed to start to normalize the parameters as well for the overburden pressure. And that's when, in the late or early 1990s, we started getting these graphs where you no longer see just a small QT, but a capital QT, which is basically a normalized version of the tip resistance. So what has happened is that over time, we went from QC to QT, and then we went to the capital QT. And that is what is really utilized in the analysis methods most today. It's a normalized version of the corrected soil tip resistance that you measure. But there's a problem. And that problem was highlighted in an article that was published not too long ago in the Canadian Geotechnical Journal. And what you see in there, and I know it's a lot of text, but I wanted to put this quote there, is that there is a problem. Yeah, when you have site investigations, you really want to make sure that you figure out all the little details. Site investigations should capture these features, the various features in the soil, to allow for a good analysis. But comb penetration tests do not adequately capture thin layering, and that's a problem. It's a well-known problem. And as a result, what was suggested in this article, that maybe we need to start looking at revealing the need to understand limitations in the current site investigations techniques. In other words, maybe go to a different type of soil investigation technique. On the other hand, underlying limitations also point out the uncertainties that Roy Santos put in his paper. So you see, it's kind of the same tone, the same. What you see here are three different cases: case 1, case 2, and case 3. And the clay layer, and underneath there you have a sand layer, a thick sand layer. And if the sand layer is thick enough, like you see in case 1, then you'll see that the tip resistance goes all the way to what the sand really is doing, the resistance that the sand is really performing. But if the sand layer gets thinner and thinner, you see that the tip resistance for that sand layer gets less and less and less. And the reason for that is that the tip resistance is really influenced by the measurements or the resistance above the tip and below the tip. It's really an averaging function there. It's not just exactly at the tip. And you see the same thing here again. What we've done here are three different cases where we show the actual resistance in the solid black lines, and then we show you in the dashed red lines what the cone would see. And you see there, if you have a very thin layer, then as you see the top part in all cases, you see that there the actual measured tip resistance, whether it be corrected or not, is a lot less than what the true tip resistance is. And that layer, that sand layer, the stiffer layer, really needs to extend quite a bit in thickness before we start seeing the true value. So that's a problem. That's an issue. And what we proposed in the paper that we put forward in the conference is an algorithm where we take the measured data, corrected for the pore pressure, potentially even normalized, and then put an algorithm on there that shows you what's really happening. And what you see here is that when you have the red line, which is what you measure, then you see the dotted traces, the black dotted traces, and you start seeing that at certain thin layers, the actual tip resistance is a lot higher than what is really measured. Now, why do I show this, and why do I not show you all the equations? The equations are not that important. They're in the papers, that's the research, that's all fine. But what I want to emphasize to you is that cone penetration data can be analyzed such that thin layers are identified. But we need to understand the uncertainties associated with the data acquisition. It brings me back to what Roy Santos was saying at CPT'22. We also need to start looking at new developments, in this case, on how to analyze the data. That is what was presented at that conference as well, where you need to be open to new developments. And that then finally brings me to an article that I wrote for this conference, where I said at CPT, it's an old and proven soil investigation method, but it has a bright and an exciting future. It's something that definitely can go on in different ways. And what you saw earlier with different ways of deploying a cone, dropping it from a drone. Is it going to be reality tomorrow, day after tomorrow? Probably not. Could it be the reality 10, 15 years or even 2 years down the road? Very possible. Already offshore, we're doing where we just basically drop a cone from from a ship and just let it sink into the soil and see what's happening there. Maybe you can do the same thing on land. So with that, I hope I have given you a flavor of CPT'22, but also the conferences in that area. I hopefully have emphasized that we cannot just take everything for granted, that the measurements that we take are perfect, that we need to be open for new developments, and hopefully that way get a better understanding on how we can utilize this exciting soil investigation technique. And also, I would strongly encourage you to find those papers from CPT 10, 14, 18, and now 22. 22 and will be online probably in the next couple of weeks to at least have a look at those papers. And if there's a specific topic that you're interested in and you cannot find those papers, please feel free to contact me at any time. Unfortunately, because of the technical problems that we had, I don't have any time for questions right now. I apologize for that, but I will answer the questions by email. With that, I want to close it. Thank you very much for being here, and I hope to see you again next month for the next edition of the CPT webinars organized by Eijkelkamp North America. Thank you very much.